Hello everyone, welcome to my channel Lazarus Repairs and welcome to my video uh, Nintendo Switch Repair number 2 part 2 The Fix. So uh, if you've watched part 1 of this Nintendo Switch repair, you'll know things didn't exactly go to plan. I had a Nintendo Switch here with a corroded charging port. I managed to get the old port removed, installed a replacement, and everything was looking pretty positive. I put the switch back together, got everything connected back up, gave it a port test. So naturally, I thought I'd done the hard bit. I pressed the power button and absolutely nothing. So that's where we left part 1. Now, this video is going to be a little bit different because by the time that I've recorded this, I've actually already prepared the Switch. So rather than pretending that I'm diagnosing this in real time, I'm going to talk you through exactly what happened after part 1, the problems that I'd found, some of the mistakes that I'd made along the way, and then most importantly, how I got this thing working again. And let me tell you, there was quite a few problems. So that's where we got to at the end of the last video, and let's pick up from where we left off. First thing that I did was take the switch apart again, because at this point, my first thought was that something had obviously gone wrong during reassembly. That turned out to be pretty much the case. I started inspecting the LCD ribbon cable and the FPC connector on the motherboard. Unfortunately, I did find damage. Now, looking back at it, I believe that this is probably something that I did myself when I was putting it back together in part 1, which is obviously not ideal. But this is one of those things that I've been learning with these repairs. Sometimes the fault that you're looking for isn't necessarily the fault that the device came in with. Sometimes it is you. And in this case, I think I'd managed to create another problem while putting the switch back together. So rather than trying to repair the damaged connector, I decided to take a connector off of a donor board, which is just here. Once that was done, I partially reassembled the switch so that I could test it, and I still had nothing. There was no display, there was no touchscreen, no sound. I plugged my ammeter in, and it jumped up to 480 milliamps. It just sat there. It wasn't doing anything. So obviously, at this point, I'm thinking, right. So now what have I done? I should say that the first time that I put it back together, I still had sound and the touchscreen was working. But once I'd reassembled it again, now I'd lost sound and touchscreen. It will become evident as to what my mistakes were with that. So I took it apart again. I reseated, gave it a clean, and reseated the LCD ribbon cable because obviously that's one of the things that I'd already been working around. Plugged it back in for another test. This time the current draw had changed. Instead of sitting at 480 milliamps, it jumped to around 127 milliamps and it stayed there. So it was different at least, but I still had no display. And at this point, I decided that I needed to just stop putting things back together and hoping for the best. I decided to remove the shields around the APU and the RAM so that I could properly inspect the board. And while doing that, I managed to send this tiny capacitor just next to the shield, absolutely flying. Didn't see where it went, couldn't find it. It had basically just disappeared. And if you've ever worked with these tiny components, you'll know exactly how frustrating that is. You've got the board covered in components that are absolutely minuscule, and then you've got one less than a millimeter wide that you're just launched into another dimension. So rather than leaving it missing, again, I went to the donor board, and I took the equivalent capacitor from the donor board and replaced it. At this stage, I later learned that this capacitor was associated with the Wi-Fi circuitry, and that will become quite important later on. While I had the board apart, I decided to give the whole thing a really thorough inspection. Remember that this switch had already suffered corrosion and liquid damage, so got the IPA out, got the brushes out, and started giving it a good clean. Got rid of as much of the corrosion and the muck and the grime as I could. And honestly, when you got a board like this, completely stripped down, it becomes so much easier to see what you're actually dealing with. After cleaning everything up and inspecting the board, I then plugged it back in for another test, and 127 milliamps again. It just sat there, and at this point, I'm scratching my head. I don't really know where to go. I've replaced the charging port. I've replaced a damaged FVC connector. I've reseated all the cables, cleaned the board, and I've replaced the capacitor with a like for like, and it's still sat at 127 amps. So this is the point where I decided that I needed to get some help. Now, before I go any further, I want to explain where the help came from, because this is actually a pretty important part of this repair. The group that I was using is called Electronics Repair, and they're over on a website called School. It's run by Joey Does Tech. If you've been watching electronics repair content on YouTube for a while, there's a good chance that you've come across Joey. Joey started his electronics repair back in 2020 and documented himself learning the trade from the ground up, built his YouTube channel around repairing faulty electronics, learning as he goes, and importantly, showing the mistakes as well as the successes. And it's one of the many reasons why I look up to him and think that what he does is just fantastic. He doesn't present things as I know everything and I'm going to show you how clever I am. It's much more about the learning, the troubleshooting, and figuring things out. And it's very much the kind of approach that I'm trying to take with this channel, Lazarus Repairs, as well. I'm still learning. I only started 2 months ago. I'm still making mistakes, and I'm definitely breaking things, which brings us nicely back to this switch. The electronics repair group on School is essentially a community that's built around learning electronics repair. You've got repair technicians and people at different stages of their journey, and the group provide things like repair resources, troubleshooting help, weekly calls, community sessions, and even one-to-one assistance with repairs. So when I got stuck in with this switch, I posted it in the group and asked for some help, and that's where RVNR Repairs comes in. RVNR is another repair technician within the community, and he offered to jump on for a one-to-one call with me to help me diagnose the problem. And honestly, this is where I learned one of the most embarrassing lessons of this entire repair. So we jumped on a call. RV started going through the board with me, looking over and inspecting what I'd done and tested. Pretty early on, he spotted something that, looking back on it, was painfully obvious. I did not have the eMMC connected. For anyone that doesn't know, the eMMC is essentially the switch's internal storage memory. And without it connected, you obviously are not going to get a normal boot. So basically, I've been sitting there staring at my current drawer, wondering why it won't boot. And I'd actually forgotten to plug the memory back in. I'm not going to lie, it was one of those moments where you just sit there thinking, yep, that'll do it. So, lesson learned. Always check your connections before assuming that you've got a catastrophic motherboard fault. So, now, back with the eMMC connected, I put enough of the switch back together to test the screen, and still no display. RV, he took another look at the FPC connector that I'd replaced earlier. So I grabbed my fine tip soldering iron, added a little more leaded solder to the connections, and made sure that the pin was properly connected, tested it again, and I still had no display. Harvey then spotted another problem, which was that the LCD ribbon cable wasn't actually pushed into the connector far enough. This was another really useful lesson to me, because there are two little tabs near the end of the ribbon cable, and they almost need to be touching the connector itself, and mine wasn't far enough in. So pushed the cable in properly, connected everything back up, gave it some power, and then bosh, charging symbol appeared on the screen, and the switch then booted normally. At this point, I was buzzing. We had a display, we had touchscreen, we had sound, controllers, they were working, everything appeared to be working, and I gave it a test. Once I had come off of the call, I carried on testing, and I had a problem. Everything was working, but I could not get it to connect to the Wi-Fi. It threw up an error code, 21101118, I believe, and this is where that tiny capacitor that I'd launched across the room earlier on came back to haunt me. I asked for some more help on the group, and this time Craft Ben Mine Repairs pointed out that the Wi-Fi problem was likely connected to the capacitor that I'd replaced earlier on, and suddenly that tiny component that I'd nearly forgotten about became very, very important. So you guessed it, the switch had to come apart again. Don't worry though, this is the last time that I had to take it apart. I went back to the area around the Wi-Fi circuitry. I removed both of the capacitors in that area. I gave it a good clean, resoldered both of the capacitors in place. I was using hot air for that. I wanted to make sure that the components were properly seated and that I had good connections. And while I had the switch apart again, I decided to have another look at the power button, because we'd already had a few issues that were caused by things that had been damaged or corroded. Kind of glad that I did, to be honest. The power button cable and the connector were showing signs of... Actually, I think I have it here. Yeah, I'm not sure if you can see that there. But this is the one that I took out, and this would be the power button here, and it is just rusted and it doesn't click. So rather than risk another problem, I decided to take the cable and the button assembly from the donor board. I replaced it, put the new one into this one, and at this point I'd repaired and or replaced enough things on the switch that I really was hoping that this would finally be the end. I put it all back together. Finally, the moment of truth. Connected everything, powered the switch up, and it worked. It booted normally, screens all working, touch screen works fine, controllers all work, sound's working, and most importantly, the Wi-Fi is working as well. Didn't have no error code. I'll put on the screen working proof. I have reset it since then, and at the moment I'm using this as a test switch because I'm going through a bunch of controller repairs. These are two of the controllers that I repaired and I placed with it. You'll see that in the first video I didn't have these ones connected. I had a blue and a red. Honestly, this repair has taught me a ridiculous amount. The biggest thing that I've taken away from it is that troubleshooting isn't always about finding one massive fault. This switch ended up with multiple problems. Some of them were existing corrosion and damage, and some were probably problems that I'd caused myself during the repair, and some were simply just mistakes during reassembly. The damaged LCD connector, the poorly seated ribbon cable, the eMMC not being connected, the questionable connection of the replacement FPC, poorly soldered capacitor, Wi-Fi fault, corroded power button problems, you name it. It was basically a collection of little problems that all added up to a switch that just wouldn't work. And that's something that I'm slowly learning with board repair. You can't just look at a device and assume that there is one fault. You have to work methodically, check your connections, check what you've changed, check what you've touched. Probably most importantly, don't forget to plug in the bloody eMMC. So that is the story of the Nintendo Switch repair number 2. I started with what looked like a fairly straightforward charging port replacement. Part 2 ended up being a much bigger repair than I expected. But that's exactly why I wanted to make this video. I'm not an electronics repair expert. I'm learning. And sometimes the best way to learn is to make mistakes, ask someone who knows more than you, and understand why you made the mistake, and hopefully not make it again. I'd like to give a massive shout out to RVNR Repairs for taking the time to jump onto that one-to-one call with me, helping work through the faults, to Joey, and also to Craft Benmine Repairs for helping me identify the likely causes of the Wi-Fi issue. And obviously thanks to everyone else in the electronics repair community who help people and share their knowledge. If you're interested in electronics repair, I'll leave information about the electronics repair community in the description. And if you've enjoyed watching me make questionable decisions with tiny Nintendo Switch components, then please consider hitting that like button and subscribing to Lazarus Repairs. It genuinely helps this channel out, and I've got plenty of more repairs coming. If you've got any questions about this repair, or you've spotted something that I could have done differently, please drop it in the comments. I'm always happy to learn. And if you haven't already watched part 1, please go and check that out as well, because that's where this whole disaster started. Thanks for watching, and I'll see you in the next one.